into that black hole, and nothing else is happening from there. Okay? All right.
Wait,
yeah?
How do they know if light is not escaping? Nobody can go near it.
Right, so any light that is that is near the black hole is getting sucked into the black hole. And it can't get back out.
Oh, okay.
So it's not glowing.
It's literally pulling
It's just
everything.
pulling it in.
Literally like a vacuum.
Pretty much. That's a perfect analogy.
But it won't release.
But it won't release it. Everything is getting sucked in. Exactly.
Where is it getting sucked
well,
into?
That's what we don't know.
I feel like it sounds so
I think
dumb.
you haven't taught it.
Where?
No, we don't know. We don't know where it goes. Okay, so let's go through this full life cycle of a star, because this is something that you will be assessed on your assessment Friday. Okay? We do. First test, not a first writing assignment.
Oh, with multiple choice?
Uh-huh.
Oh, I don't know.
No. Okay, so let's start. Okay? All right. So everybody's with me. We've grabbed this. Everybody see where it says number 1?
Yes.
So we're all in the same place. Junior, Brian, find number 1 back here, please. On this paper, find number 1. Miguel, Juan, y'all good? Yeah? Okay, number 1, everybody's got it. Okay, so the life of a star starts out as what?
Nebula.
Nebula, excellent. So number 1 is nebula. Perfect.
Did you write that?
Write that down, please.
Now you just leave it blank.
Well, I don't know where to write it.
Just
Number
next to
1.
number 1. Okay, now those are going to collapse into, bingo, protostars.
How
I'm
do you
hearing
pronounce that?
proto-star. Protostar. So I'm hearing a lot from the front of the room, back of the room. Speak up too. 2, protostar. Okay? Now, after that, somebody from the back of the room,
Main sequence.
somebody from the middle of the room's got it, somebody from the back of the room, at least you can echo. Main sequence. All right. So number 3 is the main sequence. Okay. All right. So don't get tripped up. Okay. So 3 is the main sequence. You guys see how there's arrows that go up and there's arrows that go down.
Yes.
Everybody see that? Okay.
We're going up.
We are going up. So we're going from 3 to 4. Numbers make sense, but sometimes pictures don't. Right? So.
Oh, is it because
Protostar
there's
3 is main
also
sequence.
tinier stars?
Right, because there's little stars and big stars. That's exactly right. Okay? So little stars, low mass stars in our main sequence, like our sun, become red giants or red supergiants?
Red giants.
Bingo. Red giants. Okay? Red giants. We got it? Okay. 5 then, when they start to lose all of their mass. 4 white dwarfs.
Planetary nebula.
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 I like it. Planetary nebulas, right here. Planetary nebulas, PNebs, right? PNebs, because we don't want to have to say planetary nebula. Planetary nebula. Okay? Then
It's a white dwarf.
Then it's a white dwarf. Exactly.
Wait, did they consider Pluto a white dwarf or just a dwarf?
It's a dwarf planet.
What's the difference? I mean, like, I
Small
obviously it's
planet
different, but-
versus a star. So a white dwarf is a star
Mhm.
type of star, whereas a dwarf planet is.
Just
Still
a
a
really
planet.
small planet.
Okay, cool.
But it's
So let's go back to number 3, back to the main sequence. Back to the main sequence. Okay? Because now let's talk about the big. So yes, that's exactly right. So instead of a red giant, we're going to become a super red giant.
Or 7, number 9.
7.
I
7.
went to
It's two different timelines.
Right, the top timeline versus the bottom timeline. Super red giant, yep, for 7. Okay. Then those suckers explode into
supernatural.
Supernova.
supernatural. Uh-oh.
We gotta
Easy there,
stand.
Dean.
Oh,
All right.
yes.
So supernova, right, was 8.
Mhm.
All right.
What is
So one of 2 fates. after a supernova. If you got something left over, you become a neutron star. Neutron star. Neutron star. And nothing left, Jocelyn, what do we become? A black hole. Got it. Okay. And then if you guys see 11A and 11B, when things explode, everything starts back and goes to a
Nebula.
because that is
Because that's the birth of a star.
because it's made of
Gas.
gas,
So
recycled
you just
dust.
the birth of a star.
What?
Goes back to the birth of a star.
You got it. Bingo. Okay.
Wait, so what did we
Wait,
write
so
down?
what do we write? Yeah.
Birth of a star.
Oh,
Oh,
okay.
Yeah. Birth of a star. Starts back to the beginning. Back to the beginning. Okay.
Would you
Yep.
consider,
For no, sorry, 11A and 11B. Yes, I know. What's up?
would you consider like this whole cycle the Big Bang?
No, so this is what happens in the creation of the stars, right? The Big Bang was the creation of everything. So do you remember on your Big Bang timeline, right? Whenever I know we got so much good information in here, right? Whenever the galaxies started to form, that's when the stars and the sun started to form. So it was years on our timeline.
Can we fake
At
that?
this timeline. Okay, make sense? Yeah, okay. Number 11, which one?
It's
Birth of a star. 11A and 11B are both birth of a star. Okay. Now, at the bottom here, it says the path of our sun. Does everyone see that on the bottom left? Okay.
No.
The path of our sun. Okay. So let's think through our sun. Is it a red giant or a super red giant?
It's a super red. It's gonna become a
Red
nursery.
Debate. Which one is which?
the sun.
After it kills everything.
It's a red giant.
Why is it a red giant?
Showed us some pictures and it was
I know you did compare.
Miguel, say that again.
showed some pictures.
And what were the biggest ones?
Super red
The
giant.
super red giants. And remember how much bigger
the star
Oh,
is
so was
not
that right?
big enough to be a super red giant.
Exactly. So remember how big those huge stars were compared to ours?
In order to explode,
So is it a super red?
Right, to explode. That's exactly right.
you're like
Okay. So our sun then is a red giant. That's right. Okay. So at your table, you guys figure out which path our sun would take. Talk it out. I'm going to give you about 2 minutes and write down the path our sun takes. So 2 minutes. Get it done. So which one of these paths is our sun going to take? Talk that out and then write it down here.
Wait, how does the white dwarf become a nebula?
they get smaller.
Remember, they shrink. So there's nothing left.
And then they start enlarging, right?
There you go. Yep.
And then they explode.
Exactly. In space, yes, it has no other phase. Okay.
It's just stuff constantly exploding.
Hey, listen up. So, we're talking through which path our sun takes, and then writing it down on the bottom where it says path of our sun.
Like the order?
The order, yep, that's exactly right. And in the event that I call you out and want you to individually answer for me. Right here, path of our sun. On that, on the bottom, place path of our sun. Right down to path of our sun. Okay. So you'll start right here. And follow which one is our sun. Is it the top of the water? Okay. Okay. Keep going. Like the whole path.
So that
Why are you trying to kill us?
Right, why?
No, we wouldn't be dead.
What if the die so bad?
We'd just be existing, because I'm pretty sure rocks and things still exist in here, so I feel like if we were in the
But not humans.
Well, no, like if Earth started existing in the planetary nebula phase, I think that would be cool. It's just that the white dwarf phase, I feel like that comes real quick. Like I feel like these two things are like,
Yeah, it's
you know,
really
only
fast.
like 2 billion years apart or something.
But remember, we're a planet, not a star.
Yeah, but I'm just saying, if we were in like the clouds right here, we'd have to we have to go through
So
all
you're
that.
saying if we were living in the 10 million years in 8 minutes, you don't want to be in this stage. You want to continue to see this here.
No, she wants to be in this stage.
I feel like it'd be prettier.
She just doesn't want to be alive.
Slender
She's
Man.
not even these 8 minutes straight over.
No, that one's fun. We should watch the spider jumping off.
Okay. All right. Jose, start this out for me. What do we start out as? Jose. What do we start out as? What's our star start out as? Our sun?
A nebula.
A nebula. Zilly, what happens after that? After a nebula, it's a... Shh. Sonia, don't give it away. Protostar. Okay, Sonia, what happens after that then?
No mass.
Low mass what?
No mass.
What's sequence? Yeah, main sequence. Okay, Sydney, what's after the main sequence?
The red giant.
Red giant, good. Eileen, what about after that? Pina, planetary nebula, perfect. And then one, what does it end up as at the end? Not our sun. What is our sun after planetary nebula? What's next? Let him have it. White dwarf. Excellent, excellent. So just to make sure everybody's good, nebula, protostar, main sequence, low mass, red giant, PNeb, white dwarf. Got it? Excellent. Yeah, Sydney, what's up?
I feel like our sun's not living its best life here.
Just because we want it to happen. Okay.
Are you okay?
All right. Let's slide that to the side and pull back up on our notes and finish these notes really quick because you're going to need them for the lab that we're doing today. And it's fun. And the lab is fun. It's really fun. Jose was already telling me all about it because all of his friends have already told him everything.
I know. You're trying to
Shh, don't spoil it. Don't give it away. Okay. So red giants, white dwarfs, black holes. Why do we name all of these things after colors?
Because those are that's the way that we measure how far close things are, because if it's red, it's moving away, and then if it's
White.
no, if it's
Let the woman have the room.
if it's what was it? If it was white, it's like going slowly into each other, I think. And then I don't know what the symbol is.
But
I don't know that one. That's all I
impressive.
know.
Okay,
Good job.
so it's easy to label things based on colors because we can see colors.
Right.
Right? Colors are easy to classify things as. Does that make sense?
Yeah.
Because it's visible, it's something that we know. We learn colors from forever. Okay? So hopefully in physics or hopefully in life, you've seen a rainbow before.
Yeah.
Right?
Roy G. Biv.
Hopefully, Roy G. Biv, exactly. So, right, white light, yes, white light, is made of all of those colors. Yeah? Remember that? White light is made of all of those colors, and then we use something called a prism that's going to split that into its rainbow, right, into its spectrum. Okay, so let's talk about why this matters in our class. Why does this deal with the stars? Okay, so we're at 5 on our outline, colors of the stars. So let's start out with A, the visible spectrum. Okay, so hopefully this is just a review. White light contains all colors. That's the first thing we want to write down. White light contains all colors. White light contains all colors. A prism, if you're not sure how to spell that, it's on the board. A prism will separate it into its spectrum. White light contains all colors. A prism will separate it into its spectrum. Yeah.
Where can we get prisms?
Amazon, honestly. But you'll see a way to make a homemade one today.
Yeah.
Okay.
Shush.
All right.
I'm
Okay.
ready to listen for this.
So, right, stars. Listen. Hey guys, back here. Thank you. Okay, so we see stars as white, right? When we look up into the sky at night, most of them are white. Okay. Now we could take those stars and separate them into their spectrum. Okay. We can take that white light and separate it. I'm going to slide this over a little bit so it's not in the way. you can see the spectrum, yes? Now, what do you notice? Keep that in mind, okay? That's different from this. What's the difference in the rainbow? Okay, so everybody, regular rainbow, you know what a regular rainbow looks like. How is this rainbow different? There's something in this rainbow that's missing.
There's orange right here.
Black.
I will. Here.
Okay, we got red.
Black.
There's like a light blue.
No.
Okay, that
Versus
is not it.
Light.
here.
There's no light.
It starts from dark to light. I don't know.
You said it.
Black.
There's black spots.
Oh.
Do y'all see this?
Oh, I thought that was just there to separate the
know.
colors. I was like, oh,
This
that's a part of the
visual right
picture.
here.
Bro.
There's dark spots. Now,
Be sure to not
why?
eyes.
Why are there gaps? That's our question. Why are there gaps in that spectrum? Why are there gaps? Why are there gaps? Okay. What do we think? Why would there be gaps in that spectrum?
Probably because we can't see that color.
The dark bands are the colors the element is absorbing. That's right. That's what Yuli just said, so write that down for me. The dark bands are the colors the element absorbs. So what colors then is this hydrogen absorbing? A little bit of red, some blues, and some indigo-ish purple, right? So those are the colors that hydrogen is absorbing. Now, every element has its own unique bands. Make sure you write that down. That's going to be really helpful for what we're doing today. Each element has its own unique bands. It's like a fingerprint. We all have unique fingerprints, right? Each element's going to have those unique bands, okay? So, why does this matter? Well, considering we're looking for the age and composition of the stars, why would it matter that we can see these elements? We can see these colors. Yeah, we can classify them. That's exactly right. We can classify the stars based on their elements. Write that down for me. We can classify the stars based on their elements. That's exactly right. Good job. We can classify the stars based on their elements. Okay, so let's look at how a scientist would classify the stars. So we're down to 6. Down to 6, classifying the stars. So we're going to use something called a Hertzsprung-Russell diagram. Hertzsprung-Russell. Okay, so guess what? We're almost done with notes.
Oh.
Hertzsprung-Russell. Okay, so Hertzsprung-Russell diagrams will classify according to brightness.
Yes.
Make sure you're writing these down. Brightness, elements, color, temperature, and age. Okay. Brightness, elements, color, temperature, and age. So for my HR diagram, I took up a whole page. If you've got half a page, you don't have to be as extra as me. Okay? But if you got like half a page or a back page that's free that you can use, do that. So we're gonna set this up our HR diagram. Oops, I can stay there. Just like you would set up a regular graph with an x and a y axis. Okay? You can do this with markers, you can do this with pen or pencil, but I did put a new pack of markers at your table because you'll need them for a few minutes. Okay, so go ahead and set up your x and your y axis. We're going to label them. Go ahead and we're going to set up our x and our y. Okay? Everybody got an x and a y? You should have time. Yeah. We're doing all the subjects. We did poetry. Now we've got some math. Okay, so let's label our x-axis temperature. If you can't see this, that's literally all that's written down here is temperature. Okay, we're going to label our y-axis brightness. Now, if this were a math class, right, there'd be a 0 right here. But guess what? This ain't a math class, so don't write a 0.
Oh man.
Okay? Now, normally, right, you'd want 0 and then you'd go on your x-axis up, in your upper number line, right? Well, this time around, we want increasing temperature to the left. So your highest temperatures will be here. So go ahead and write that down on your graph. High temperatures on the left. And low temperatures on the right. So 0 would be closer to here. Okay? So if you need that 0 as a reference, make sure that you're writing your 0 somewhere over here. Okay? Alright. Now, on our y, it's just normal. Increasing brightness, looks like it should be where it is. Decreasing brightness, looks like it should be where it belongs. Okay. Now here's where you're going to need your pretty colors. Okay. Our coolest stars are our red stars. Yeah, I worked hard. Okay. So what we want to do on our cool temperatures, low brightness, draw some red stars. I gave you some red markers. Look, don't draw actual stars too once. Okay, for the sake of time, so we can actually get to some looking at some lights. Nope, just like that, but instead of blue stars, 2 dots.
But it's because yours is pretty and mine is
It's gonna be pretty.